Okay, we'll get underway. So good afternoon, everyone. Thank you for joining us today. This is April's Lunch and Learn webinar. BCIA hosts these webinars, they're monthly, and we do them in partnership with a manufacturer each month. They're intended really as an opportunity for bite-sized learning, and so that you can meet the representatives and the teams from the manufacturers. Today, it's a CPD accredited webinar, and I'll be handing you over shortly to Ian Ellis from Siemens, and he's going to be taking a dive into ISO 52120. The webinars are intended to be interactive, so do ask questions by either using the raise hand function, popping them in the chat, or there'll be time at the end, plenty of time at the end for questions and answers. So feel free to wait until then if you'd prefer to do so. We'd really love you to be as present as possible, if you don't mind. If you want to put your cameras on, so that you're fully engaged, feel free to do so. We would like that. Equally, if you could keep your microphones just on mute, unless you're asking a question, of course, just to prevent any background noise or feedback coming through. Just so that you know, the webinar's recorded, but it will be available on the BCIA YouTube channel shortly after the webinar's finished. Ian will be able to explain about the CPD certificate as part of his part as well. So I won't delay it any further, really. I'll get the webinar underway and hand you over now to Ian Ellis from Siemens.
Thanks. So, hi everyone. As Catherine said, my name's Ian Ellis. I'm the marketing manager for Siemens buildings in the UK and Ireland. But don't worry, I'm not going to give you a hard marketing sell on Siemens. Really, what I want to talk about is a specific standard that I think benefits us all in the BMS industry, whether we're manufacturers, consultants, systems houses, distributors, whatever. So I'm going to go into a bit of detail about that. Just a quick mention. So Siemens Buildings, we are one of the world's largest manufacturers of BMS systems and peripheral devices as well. So really we do everything from sensors, valves and actuators, damper actuators, meters, right up to BMS systems, automation controllers, terminal unit controllers, and our Building X IoT enabled cloud platform now. So that's the hard sell over. If you'd like to find out more, you can see behind me every 2 years actually Siemens does a big event called Transform at Manchester Central, which is not just my part of Siemens, it's the wider Siemens offering. And if you're interested, then again reach out, or there's lots about it on LinkedIn. But what I'm going to do is go to my presentation, so hopefully that comes up now. And as Catherine mentioned, this presentation is CIBSE approved for CPD points, 45 minutes worth of points. So if you do want the points, please drop me an email or message me on LinkedIn at the end, and I'll get a certificate over to you. That's no problem. So what I want to talk about is this standard. It's a standard called the ISO 52120 standard. Just rolls off the tongue, as you got it there in my head. And this replaces a previous European standard, which some of you may have been aware of, called EN 15232. But basically, the two things are exactly the same. It's just that it's now an ISO one, so it's an international rather than just a European one. But those of you that are very British centric and like to vote reform, if that's the sort of thing you like to do, it's also a British standard as well. So it goes right down to UK level, but then up to international level. And the title of the standard is The Impact of Building Automation on Energy Efficiency. So I'm going to just run you through where the standard came from. Excuse me. yeah, where it came from, background to sort of where it was delivered from, how it fits into some of the UK legislation or building regulations. Then I'm going to touch on a bit what the standard actually says, and what it does and how that can be useful for all of us in the BMS world. And then I'm going to give you one practical example. Those of you that know me will know I'm not the world's most technical person, so I'm not going to insult anyone's intelligence with my knowledge or lack of knowledge of building management systems and HVAC plant control. But I will give you one example, a very simple one, just to show how the standard actually works in action. So now I'm going to start with this again. Hopefully I'm preaching to the converted, but I think it's always good just to have a starting point as to, why BMS is important, and where the standard derived from. So if we look at energy consumption, and I guess at the moment energy consumption again is a topic. I mean, it's never gone away, but different world events make us think about it more. But if we look at how all energy is consumed globally, I mean, these figures take into account the EU, but it's a very similar pattern globally. And when this talks about the EU, again, I know we're no longer in the EU in the United Kingdom, but the United Kingdom has the same sort of conditions as the rest of the EU. So these facts do apply to us in the UK as well. But 40% of all energy consumption is within buildings. And when I say within buildings, or when this talks about it being within buildings, that's in terms of what happens within those buildings in terms of keeping us a comfortable temperature, having lighting within the buildings, looking at environmental conditions and things like that. It's not to do with the build, it's actually the day-to-day running of buildings use about 40% of all energy consumption. If you're interested, the other 70% is made up of transportation and then actually the means of production within buildings. So actually sort of factory automation and so on. And consequently, that has an effect on CO2 emissions as well. So again, buildings are the biggest single sector that generate energy consumption and as a result CO2 emissions. So there's lots of things we can do, and again, I'm not insulting anyone's intelligence on the call, but there's lots of things we can do to make buildings more energy efficient, not just BMS systems. Obviously we can look at how we build this buildings, the sort of insulation we use, the windows, the brickwork, the fabric, all that sort of stuff. And that's great with if I was building a new building today, it's very good. I can look at Part L or whatever and think, right, what materials can I use to help me make that building more energy efficient than a different style of building. But the challenge we have is a lot of buildings have been up for a lot of time. And again, this study comes up with a figure, 35% of all EU buildings are over 50 years old. So it's very difficult, or it can be very difficult and potentially very costly to try and change the building itself. So what can we do to make that building more energy efficient is where we're really coming from. And also based on studies that have done, and there's a link on the presentation to one of these studies, if you actually look at buildings, 75% of them that are up are found to be energy inefficient. And we all know this scenario. You drive through a city centre at night, whether it's London, Edinburgh, Belfast, Cardiff, you name it, Manchester, and we still see buildings with all the lights on and there's no one in there. And it's a pretty fair assumption, if the lights are on, probably the building's still being heated and cooled to maintain 20-21 degrees in there. So there's a lot of energy inefficient buildings out there, and really that's where BMS comes in, because a lot of the thing about a 50-year-old building, you can still put the latest BMS in there regardless of manufacturer and make that building more energy efficient. And you may already have a BMS in a building, but it may not be being looked after properly. It may not have all the functionality in there, all the sensors it needs. So again, with a BMS, we can help drive down the number of buildings that are energy efficient. Again, hopefully I'm preaching to the converted on the call, but it's always good to just have that as a starting point. And the EU realised this. So the EU, and at the time the UK was still a member country. So back in 2003, and again, many of you, if not all of you on the call, will know about this already, but they came up with something called the Energy Performance of Buildings Directive, or EPBD. The first one came out in 2003, and there have been various iterations as it's gone on. Basically, each time there's been an iteration, it's tried to tighten the conditions and make buildings more energy efficient as a result. And the EPBD looked at all sorts of things that can make buildings more efficient. But one of the things they did, they set up a technical committee called CEN TC247, which looked at the effect that controls or building automation systems can have on energy efficiency. And as a result, that group sat, and if I remember correctly, I think the BCIA were involved at the time, or we might have still been called the BCG in those days. But we, along with other organisations across the whole of Europe, across the whole of the EU, came up with this standard, which initially was called EN 15232. And it looked at the impact of BACs on energy efficiency. Now, any of you that work for a big organisation like me working for Siemens, and I'm sure it's the same in all organisations, we all love acronyms. So just to explain the acronym, BAC stands for Building Automation and Control Systems. So when the standard talks about BACs, that's what it's talking about. And a building automation and control system is a BMS, or a BMS, if you like to call them, whatever you like to call it. But it's basically talking about the effect that BMS systems can have on energy efficiency in a building. And what's really good, why we as Siemens like the standard, is it just looks at the effect BMS systems can have. So me working in Siemens buildings, or people in other BMS manufacturers, we can point to this standard and say, if you just get your BMS right, you can save potentially this amount of energy within your building. You don't have to do anything else to gain this amount of energy efficiency. Yes, of course, you can still do other things like get more energy efficient boilers or chillers, or increase the insulation in the roof, or change the window types, whatever. You can get other gains, but this standard is purely looking at the effect that the BMS system or the BAC system has on the energy efficiency within that building. And it is a British standard. So as I said at the start, although it's an international standard, it's been taken down to there is a BSI document which covers the standard, which you can buy off the BSI website today if you so desire. And what I'm going to do is go through a bit what the standard actually does. The nice thing about the standard is it's not one of these standards that's written in legalese and talks about lots of different clauses and refer here and refer there. It's basically built on various different tables looking at different levels of control. And as I say, I'll delve into a bit more detail in a second about that. But yes, it's a British standard. And it is referenced within the building regulations in the UK. So if you look in the English building regulations, of course, we have different regulations for the 4 home nations. But if you look in the English one, in the approved document for Part L, and you go through it, and you find the building automation and control system specification, it gives you some ideas about what you should do. And remember, these are only guides, these aren't mandatory, but it gives you an idea of what you should do. And then at the end, if you can see it on the screen, the very bottom line says, no, a BSEN 15232 Class A rated system would meet these requirements. So remember that Class A thing. I'll come back to what Class A is in a minute. And certainly when I last looked at the Part L document, and I must admit I don't look at it every day, but it's still referred to the European standard, but obviously ISO is the same standard, just at an international level rather than just a Europe-wide one. So it's referenced within there. Not everyone's aware of that. It's one of the reasons why we put this CPD together, to try and raise the profile of it, but it's within there. If you're in Scotland, again, it's within the compliance guide there. And again, it's exactly the same statement that's in the English version. So again, a BSEN 15232 Class A rated system would meet the requirements that they're suggesting is done to get the best out of a BMS system. And it's in there. And also, oops. Sorry, I go the right way. It's in the Welsh regulations as well. So again, in Wales, they have an approved document. And again, exactly the same statement as the previous two. I haven't got the Northern Irish one on here. I apologise. I presume it's in there, but I need to check that. But certainly it's in the English, Scottish and Welsh regulations, exactly the same statement in all three. So what does the standard actually do? What does it tell you, and how can you then use it to understand what sort of energy efficiency you will get with a BMS, and why there are different levels of BMS that you can put into a building? That's nothing to do with how good manufacturer A is against manufacturer B. It's looking at how the system is designed. And it basically breaks that down into 4 classes, because we're a bit more simple in the BMS world than some other things. If you look at your fridge or your car, you get a lot more than A to D now. But this standard, it classifies, there are 4 levels of control you can apply to a building, starting at D being the worst case scenario, C being what is assumed to be the norm or the standard, based on a lot of research where they've gone around looking at lots of different buildings across the EU and said what level of control is in there now, which is there. And again, it's using this BACS acronym. Sorry. Then if you go up the scale, you get to B, which is better, and that talks about having an advanced performance system, and it brings something else in. So as well as having that acronym BACS, it adds a second acronym, TBM, which it calls technical building management. And really, when you delve into the standard a bit more, a lot of the TBM elements are about really not just installing the BMS and then walking off site and never worrying about it again. It's how you all manage, how the system is managed throughout the life cycle of the building. And much as I'd love to tell you, and with the things of AI and all that, that BMS systems are, self-adapting. Yes, we have a lot of that, but still you need to have an element of service, of maintenance, of looking at the data that you're getting out of the systems and really fine-tuning the BMS as a result. And the standard recognizes that, which is good for us, because we tell people that's what you should do, but also good for installer companies, systems houses, because it can help justify why you need to have proper service and maintenance regimes, why if you're collecting data, you really need to analyze it properly and use that to drive performance. And Class A, again, uses the BACS and TBM, but it goes into a bit more detail, or requires a bit more control. The standard, as I've already mentioned, only looks at the effect of your BACS or your BMS on the energy efficiency of a building, and it is manufacturer neutral. So it's not a Siemens standard or a Trend standard or a Distech standard or a Tritium standard or a Schneider standard. Other BMS systems are available. Apologies if there's another manufacturer on the call that I've missed out. It's not specific to any one of us. It just says, here's how you design a system. These are the elements of control you need to put into that system to get one of these classes. This is how you can move from one class to another class within the standard. You then go away and choose whose system you want to buy, as long as they can achieve whatever standard you're at. And to be honest, everyone can these days, or certainly the major manufacturers that are BCIA members and that will definitely be able to achieve that. So really, what is the standard telling you? As you go up through those grades from D to A, what do you need to do to move up those grades? And the standard really is about, and hopefully this won't come to a shock on anyone on the call, it's about to achieve maximum energy efficiency, you need to use demand control regimes. So by that, what the standard means is you need to look at, is there actually a requirement at a particular time in the day, in a particular part of a building or across the whole building, for certain things to be happening? Do you need heating and cooling? Do you need lighting at a particular time in the day or night? If you do, fine, but then try and control to the best way possible. But if you don't leave things on. Don't keep heating a meeting room to 21 degrees or heating and cooling it to maintain 21 degrees in that meeting room if there's no one in it. You're wasting energy. There's no need for you to do that. And by the same token, if there's no one in the room, why do the lights need to be on if you've got the ability to control lights within the system, as an example? So it's all around demand-based control in terms of occupancy and things like that. There are other elements as well about how you control and manage and so on, but that's the fundamental philosophy behind the system, behind the standard. Sorry. And the way the standard then defines how you get to those different classes is, as I mentioned earlier, there's a series of tables within the standard that looks at all the different things that you would potentially control with a BMS system in a building. So there's 7 categories, and I should really have put this on the slide, but hopefully I can remember the 7. So there's heating, cooling, ventilation, domestic hot water or hot water for taps, whatever, lighting, blinds, and then there's how you actually manage your BMS system. So that's that TBM bit I spoke about earlier. So they're the 7 elements. If you're not controlling all of those elements, the standard doesn't mind. You can exclude those as you do your design or your survey. And then for each of those elements, there's a section within the standard. So if I just take the example I've got on here, we've got heating control, which is in blue on the top of this sort of chart to the left. So this is looking at heating control. And then below that, it says emission control. Now, the one thing I will say, the standard was initially written in German and it's been translated into English and other languages, of course. And sometimes you just have to be a little mindful of what they mean. So when it talks about emission control for heating, it's not talking about CO2 emissions or carbon dioxide emissions or anything like that. It's talking about how you control the device or devices that are emitting heat throughout the building or to different parts of that building. So traditionally that would be a boiler. I mean, it could be a heat pump, it could be whatever you want. But for my example, I'm going to say it's a boiler because I'm a simple man and I sort of understand what a boiler does. So we've got that emission control bit there. To the top right of the chart, there's in a sort of orangey brown color, there's a thing that says definition of classes. And then there's there's two subsections, one that says residential and one that says non-residential. You can apply the standard to if you're doing a design for a residential building, but we tend to use it in the non-residential sector or the commercial sector. And then below that, you've got B, C, B, and A for both residential and non-residential, and they're the classes I talked about before. So then under emission control, the first option it gives me is I could have no automatic control. So I've just got a boiler that's throwing out heat at 70, 80 degrees, and it's just throwing that out to the system, whether you've got radiators, fan coils, whatever, it's just doing it. So I've got no level of automatic control at all. And yes, there are buildings out there that still exist that would have that. And then if I follow that no automatic control across the horizontal plane, you'll see that the first box is coloured in a yellow colour, and that corresponds to the D column. So it's saying if I design a system like that to manage my heating control, my boilers, for example, I'm controlling them to class D of the standard. The next one down, central automatic control. So again, I may be putting in a bit more control to the boilers themselves, but I'm still then just putting that heat out into the building, and that's still classed as a class D control. The next one down says individual control by thermostatic valves or electronic controller. So this is then saying the boilers are sending heat out into various rooms or offices or whatever they might be within a building. And within those rooms, I've got, for example, thermostatic radiator valves. So again, if the room's getting too hot, or if I've got a controller in the room, I'm managing the temperature within that space so that it's not getting too hot for the incumbents of that room. And that is classed as a class C. So that's sort of pretty standard system that you see in a lot of buildings still today. But then the next one down says, well, I can go a bit further. So to get to class B, I have the individual room control again, but I have some sort of feedback or communication between the controllers in the individual rooms or spaces back to my BMS system. So then I can say, well, I've got 10 rooms that I'm feeding from this boiler, but at the moment only 3 of them actually have a requirement for heat. The BMS can then make a decision to either turn down the boiler set point or turn it off. So I've added another level of control, and I've increased or gone up the scale going towards B, or I've got towards B on that one. And then the final option is again having the individual room control, but also then having some sort of demand control or demand indication, whether that's that room, if I take an example as a room, whether that room is actually occupied, even though it might be during normal working hours. So let's say it's a conference room or a meeting room, it might not be being used the whole time. So some sort of feedback to say, no, there's no one in that space. Again, the BMS can then make a decision to start turning boilers down or turning them off, or if it's a multi-boiler system, maybe you don't need all 4 boilers or however many there are in there. So you can use that to design a system from day one. Or another good thing for us in the industry is if someone's got an existing building, I can use the standard to do an assessment of what level of control is in there now. And rather than do what sometimes happens when people do an upgrade of a BMS, I'm not saying it always happens, but yeah, okay, you might change the old controllers because they're proprietary to a backnet controller. You might change the room sensors from I Siemens, you may know, took over Landis & Gyr. We used to have some, they were quite in vogue in the 80s, but brown room sensors, which probably are not to today's modern tastes. People change the room sensors to the new snazzy looking ones that we have now, but they don't actually take the opportunity necessarily to look at the control strategies that are within that building and say, could something better be done in terms of level of control? Now, the one thing to say with all of this, as you're going up the classes from D to A, as you can see here, and again, I know you're all in the control industry, so I'm not here to insult anyone's intelligence, but I'm adding levels of control. I'm probably adding additional control equipment. If I take the simple example of if I add an occupancy sensor into a room that hasn't had one, yes, I'm adding another device. Let's say I make that a CO2 sensor rather than just an occupancy detector, rather than just an on-off occupancy detector. I'm adding probably a bit more cost in. So there's more initial capital cost to go from a Class D system to an A system, or if you're doing the design, you need more controls in a Class A than a Class D. So yes, happy days for us as manufacturers, we sell more kit. But what the standard accepts that, but it then says we can calculate what the payback period will be if you make that additional investment, or you go for the higher class system, the better class system. And if you don't, these are the consequences. So again, if you've done a design to Class A and someone says, oh no, I can't really afford that, I want to value engineer it down, I need to take all these CO2 sensors out that you've put in all the meeting rooms because there's a cost of the CO2 sensors, there's more cabling required to get that back to the BMS, there's more engineering required at the BMS level and so on. You can say, yeah, okay, that's fine, you can do that, but these are the costs, or these are the effects that's going to have on the running costs of your building by doing that. So it's a way of helping to say, do you really want to value engineer this job? So that can help as well. I'm not going to go through the whole standard. You'll be delighted to know that's just one example, but there are similar tables then for how you control the hot water, how you control the lights, blinds, ventilation systems, cooling systems within there, and also the bit about how you manage the system itself. So you can see all that within the standard. And as it says in the box at the bottom, as I mentioned earlier, the standard assumes that most buildings that are out there have a BMS system running to Class C, and they've done a lot of research on this. There are figures behind why they believe that to be the case. And again, if I take the example of the CO2 sensor in the meeting room, if you go to most buildings that have been up for a while, it's still not the norm, I would say, to see a CO2 sensor in a meeting room or an occupancy sensor. Yes, there are some, and we're seeing more. I know anecdotal evidence from our organisation, I'm sure it's the same for others, we sell more CO2 sensors, for example, now than we ever did. And I'm sure we're not the only ones that are doing that. So it is growing, but think about a lot of buildings you've been in. I know, dare I say it, within Siemens head office at the moment, we don't have CO2 sensors in our meeting room. So it's an opportunity to upgrade. So the different classes will give you different options, but also the standard recognises that to control on demand, not all buildings are the same. Not all buildings have the same sort of occupancy patterns. So to calculate the potential energy savings from then going from a C to an A, the standard is not so broad brush that it just says, if ever you go from a C to an A, you're going to get this potential savings. It gives you the chance to look at different buildings with different profiles and apply that to that calculation as well. So there are 7 building types that the standard refers to. You can see them on there. The question we normally get then asked is, well, what if my building isn't one of these types of buildings? Does that mean I can't use the standard? And the answer is no, it doesn't mean you can't use it. You just look at the prospective occupancy patterns of the building you're looking to apply the standard to. You find the one of these that is closest to that, and you then use that as part of for the calculation side of it. And you could also, I mean, for example, hospitals, they assume 24-hour operation, whereas an office is sort of a 9 to 5 type operation. I know building occupancy patterns have changed in recent years, but just as a guide. But if you had a hospital with some day clinics, you could use the hospital profile for the wards, for example, but then the office profile for the day clinics. So you can still mix and match across big buildings or bigger estates and do it that way. And then by taking those two factors, so the different classes and the different occupancy patterns, these are the figures that the standard sort of puts out there as the potential energy savings you can get going from a Class C to a Class A design, or if you've got an existing Class C building, BMS within a building, if you upgrade that to a Class A, these are the sort of levels you can expect to get. It is broad brush. You don't put in specifics about the specific building, so you don't put in square meterage or number of windows or level of insulation or anything like that. It doesn't go down to that level. It is broad brush, but it just says if you changed the control design from a C to an A, whether it's in a design stage or in a upgrade or refurbishment, these are the sort of levels you see. And if you look at, I would suggest every BMS manufacturer's website, including ours, but I know it's true for all the others. We all say somewhere, upgrade your system to the latest level, you will get around 30% energy savings. And that's the sort of average across these, which we're all deriving from the standard. Or my opinion is we're deriving that from the standard. Obviously, I can't speak for other manufacturers, but that would be my assumption. That's certainly why we are confident to put that in our material and so on, because we can always reference it back to this standard. So a little bit more detail of how it does this. Looks a very busy slide, but I'll quickly go through it. Down the left-hand column, you have the different building types based on those occupancy profiles. You then have across the top two sort of big columns, one that says thermal energy and one that says electrical energy, because the standard does allow you to differentiate between the two within it. And then if we just look at the thermal one, we have 4 columns between there saying D, C, B and A. And the C column, which if you remember I said is it assumed to be the norm, the C column has got a 1 in it regardless of building type, and that 1 equates to energy usage in that building if you design to a Class C. So what does the 1 mean? Well, it can mean whatever you want it to be. It's just a datum figure, but it could be pound notes, it could be kilowatts. If you're old, it could be therms, it can be whatever you want to be, but it's the energy consumption. And then if we just take the first row, the offices row, to the left as you're looking of the C column, you've got the D column, which says 1,51. Apologies, I work, well, not apologies, but I work for a German company or headquartered in Germany and Switzerland company. We use commas instead of decimal points. Don't ask me why, I don't know the answer. So that is 1.51. And then if you go to the right of the C, you get to 0.8 and then 0.7. And that's really, when what it's saying is you've got an office, if it's got a system designed to Class C, it's using 1 unit of energy. If you take that same building, you don't do anything else but change either the design or the actual control system that's in there to an A, you will now only use 0.7 of the amount of energy. So once I know that, and if I know the energy usage of the building, and if it's an existing building, I think I can then quite quickly do a calculation as to, okay, if I make the changes from a C to an A, I've got a capital cost of X, but I'm going to save this amount of energy a year. So let's say 30% of energy a year. How quickly, based on my capital investment, will I get my money back? And then once I've got my money back on my capital investment, then I'm going to continue to achieve those energy savings year on year. So again, it's a powerful way of demonstrating why you go to the best possible design BMS system. And here's a very quick example, as I say, and those of you that know me, I'm not the world's most technical person. I went into marketing because I thought it would be an easier life than having to crawl around plant rooms and stuff like that. But here's a schematic of a ventilation plant feeding a restaurant space. So this could be, for example, our previous office at Siemens. We used to be in quite a big office in a place called Frimley. We had a staff canteen within there, and the offices were on average occupied between 8 and 5, but the canteen was open 8 till 9 for breakfast, and then 12 till 2 for lunch. But the rest of the time it was unoccupied. It wasn't used for anything else, that space. And that's true of a lot of examples, or that could be a meeting room, for example. So to the right, so we've got heating and cooling with valves on. We've then got the room with the space itself with a sensor in there, B5, which is a temperature sensor. So pretty standard design. We're controlling the temperature, we're controlling the heating and cooling valves based on temperature, and there'll probably be a time program in there, but it will probably be the same time program as the rest of the building. So it'll be 8 till 5, assuming occupancy. And yeah, that's fine. That's pretty bog standard. That's, I could take you to 100 buildings today and they would have that sort of control system in there. And the standard would define that as a Class C control system. Oops. But then if I want to do the right thing, so if I'm doing a retrofit, or if this was still in the design stage, and I said, well, no, I want to make that better. I want to make that more energy efficient. How can I do that? I defer to the standard. It would tell me to add some form of occupancy detector within that space. Even better would be an air quality detector, because then I can look at the CO2 levels and control not just on, is there anyone in there or no one in there, but how many people are in there, what do I need to do in terms of the ventilation and so on. But I add the additional sensor in there, this B4 sensor. So yes, there's a cost to add that sensor. There's the cost of the sensor. There's the cable back to the BMS, unless it's wireless, but then you'd still need some form of wireless gateway to pick up the information. That's another point on my BMS system. So I need to allow an I/O point, whether it's a module or an automation controller with onboard I/O, but I need to allow that. There's a bit of engineering required because I'd have to do something with that sensor input, and I'd probably add it to a graphic if I had graphics on the system. So there's a bit of engineering required there. So yes, there's a cost, but what are the effects in terms of operational costs that adding that sensor will give me? So here's another table from the standard. It's looking at the ventilation and air conditioning control, and the initial example with just the temperature sensor in there is this purple one going across. It says time control, but it means it assumes time and a temperature sensor being in there. So there's some form of control on there, but purely based on temperature. And if I follow that across to the non-residential part of the table for the standard, it says to me that's a Class C system or Class C design for that. And then if I do the proposed change I made, if I add that air quality sensor in there, so I've now got demand-based control within there, so I can tell if the space is occupied or not and how many people are in there, and I can manage the ventilation system accordingly as a result of that data. Then I'm taking it to a Class A system. And if you look down the bottom of this thing, it's saying I've gone from Class C with an energy factor of 1 to a Class A system with an energy factor of 0.68 in this specific example. So my energy consumption is reduced by that amount. And I'm now being very idealistic, if I was sub-metering that bit of plant, I would know what the energy costs are today if it was a retrofit. I would then be able to calculate by multiplying those costs by 0.68 what the energy cost will go down to in the future. And then I can look at, well, how much is it going to cost me to add that sensor? How quick is the payback period? Is it worth me doing it? Yes or no? And use it from there. So, and in some cases it might be no, because the energy consumption is so small. But in most cases, we tend to see on average sort of 18 months to 2 year payback period from going from a Class C to Class A. That's what the standard talks about as well. So it's quite a quick payback period in relative terms. So that's just one example, but obviously you can apply that to all the different control elements within a building. And really, this brings us down to why we're suggesting people use the standard as a way of designing systems, trying to prevent value engineering of systems, and also if you're retrofitting an existing system, trying to improve the controllability and the energy efficiency of that control. So if you start down the bottom right hand corner, I've heard this, and I do work in marketing, so I apologize, but I've heard this called the virtuous circle of control. Hopefully you haven't had your lunch yet, so you can cope with that. But basically you specify and install based on looking at the standard to design to Class A, if at all possible, or that's what you should try and do. But you still then need to monitor and analyze, is that Class A system performing in the way you expected it to? And this is this TBM bit, this total building management. So it's not just fit and forget. It's really, let's drive the BMS system to get the maximum benefits in terms of energy efficiency, in terms of carbon emissions, and also in terms of benefits to the end client, ultimately to the building owner or the building user. So monitor and analyze, and then decide, do you need to do more? Do you need additional automation or additional devices to really drive that? Again, refer back to the standard. What do I need to do? But also it might be you need to adapt the operational parameters. And I'm not going to go into, again, just one quick example, which is a bit of a schoolgirl error that we still see on a lot of BMS systems, or some BMS systems, again, regardless of manufacturer. People set the heating and cooling set points at exactly the same value. They don't put a dead zone between the two. The standard specifically says, and again, it's controls 101. I know to a lot of you that are on the call, but if you're setting up heating and cooling, make sure you have a dead band between the two. If you don't, you haven't got a Class A system. So it's not just the hardware, it's also how the system is set up and so on that's within the standard. And then if you need the additional parameter changes or additional equipment to deliver, you go back and you specify, or you try and build your design on ISO 52120 Class A again. Oops. So that's the standard. If you'd like to know more about it, this is from a Siemens perspective, my first slide, but I'll show you another slide in a minute. We have a document that goes through the standard. So it's not a reprint of the standard, but it does show you the tables that are within the standard, and explains how and why changes can be made. Full disclosure, there is a bit at the start and the end that tells you how wonderful Siemens is and our products are, but if you don't want to read that bit, you don't have to, but that's available. We also have an online tool, which we call the EPC tool, which is, again, based on this. What it allows you to do is it assumes you've got an existing building, or you're writing a specification for a building. You can look at, if I take the example of an existing building, you can go through the standard on this online tool. You can put in what's actually there, so how the boilers are being controlled, how the chillers are being controlled, and so on and so on. And that gives you a today. And then you can say, right, I'm now going to do this to take it, if it comes out as, say, a Class C to a Class A. This is what I'm going to do to improve it. The tool then allows you to put in values for energy consumption if you know them on that existing building, if it is an existing building, and you can see the difference in terms of cost of the performance of the building in terms of energy efficiency from a Class C control system to a Class A. This is freeware. It's available on the internet. Again, if you'd like to know more, I can send you the link. It doesn't give you Siemens devices at the end of it, so you could use it to look at a different manufacturer's system. It doesn't care what system it is. It's purely looking at the standard. So it's just saying, this is how it's being controlled today. This is how it's going to be controlled in the future. What are the energy savings potential there? So that's available on the internet. The first time you go to it, it just asks you to log in. So you register as a user on it, and then it's yours to use, and it will save projects. And if colleagues of yours are using it as well, then you can save the projects and send them to others. So you can use it as a design for a system and so on. And then from a BCIA point of view, so if you don't want to look at the Siemens things, or you want something independent, totally independent, although as I say, the two things on the previous slide are independent. They're not really talking about our products, solutions. But the BCIA has two technical guides. One talks about more general regulations, but ISO 52120 is in there, and there is one on the standard itself. So I think that one's 4 pages that gives you a bit of detail of what I've gone through. When I went in this morning, it does still talk about the European standard rather than the ISO one, but I think that's being worked on. But it's the same standard. Nothing changed when it went from an EN standard to an ISO standard, other than the name of it. And that's it. I hope that's been interesting, useful, maybe something you were aware of already, or maybe something you didn't know. If you'd like to know more, either contact Catherine or contact me direct. I'm on LinkedIn, and as I said, if you want a CPD certificate for listening to this, just either drop me or Catherine a line, and I'll do that. I'm not going to do it automatically for everyone, because I know some people probably don't want them. So if you do want one, please just, I would say, either go through Catherine or myself and drop me a line. And yeah, any questions? I don't know if there was any in the chat.
There's none in the chat, but we've got a hand raised, Zoe.
Hey, Ian, thank you very much. That was interesting. I use the Siemens EPC tool. I think it's really good, and as you say, it's not really Siemens at all. I haven't been able to, obviously you'll want us to use that one because it is the Siemens one, but I haven't been able to find an equivalent anywhere. And I guess my concern is if someone within Siemens no longer maintains that tool, the ability to do those calculations goes. Do you know if there is an equivalent somewhere, or where like that back-end data is, if that's possible to get from?
I'm not.
Or are you just going to promise that you'll maintain that for the rest of my career?
I promise. I can give you a pinky promise if you like. But I mean, from Siemens' point of view, we are committed to keeping that tool going. As far as I'm aware, I mean, famous last words, I know, but it's something we like the standard. We think it gives a good view of the value of BMS. So we'll continue to do it. I think. So there's an organisation called UBAC, who some of you may know, which is the European sort of equivalent to the BCIA, although it's manufacturers only as far as I'm aware. But at one point they certainly had a tool that would allow you to do the calculations. So it's probably worth looking on their website as well. I don't think they have an online tool, but the initial version of our tool before we went a bit up market a few years ago was basically an Excel spreadsheet, because it is just it's just calculations in there. So I as I say, I think UBAC have something. I'm not
Okay, thank
aware
you.
of any other manufacturers doing something. I don't know if there's anyone on the call who, from another manufacturer who does it, but I've not seen it.
Well, thank you for doing it.
Any other questions from anybody? While you've got Ian's expertise. Doesn't look like it, Ian. Thank you very much. That was hugely insightful, and hopefully everybody's found it really valuable. As Ian's said, you can contact him should you want your certificate, or if you've got any other questions, or you can come through me. It's not a problem.